then you write the definition and diagram. Look, in uh, in the wave, or when the particles are transferring energy, that time the energy of the particle always not the same. Like we told you that the particles are moving up and down, right? In
Yes,
in
sir.
the example of the deeper, straight deeper, we told that water particles are moving up, but not all the particles are having the same energy. That's why they all are not moving up in the same way. Some of the particles who has less energy, they are moving up less. Okay, and they who have more energy, they are jumping up more up. Like in our condition also, the sometimes we see that the boys are playing, the girls are playing, the girls or boys, they who have more energies, more stronger, they can jump up more, isn't it? And they who has less energy or less stronger, they are not they cannot jump that much higher, right? Isn't it? Hello.
Yes, sir.
Yes, sir.
So this way you see it is this line, you see this line, this black line, straight line, horizontal line, this one is showing you the rest position of the particles, and the red line here is showing the amplitudes, the displacements of the particles. Okay, look here, I am showing more elaborately this one. Like here, the particles here, for example, here is one. I am showing only few. Huh? There are lots of thousands of molecules are here. So from here, one particle is moving little bit, right? Little bit up. So it is uh, jumping till here. It has less energy, and one particle has a little bit more energy, so it's jumping up more, right? Its displacement is
Yes,
this
sir.
much. From the
Mm-hmm.
rest position, its displacement is this much. Then some particles have more energy, they are jumping more up, their displacement is this much, huh? And the particles which one has maximum displacement from the rest position, you see it's here, right? So this one is called amplitude. Is it clear to you?
Yes,
Hello.
sir.
So after understanding this
Sir.
one, you have not only particles are moving up, they are also moving down, isn't it?
Mm-hmm.
They from the rest position, they are also moving down. Same way, when they have less energy, they are moving little bit down. Then a bit more energy, moving more down. The displacement is more here. And for the maximum displacement downwards, this is amplitude. So from here we are getting another information that in a complete wave, in a complete wave we have one crest and one trough. So we are having one amplitude for crest and another amplitude for trough. Is it clear?
Yes,
Is it
sir.
clear to you? So you understand now the whole thing, the amplitude you understand. Now you will understand the definition, right? Can you read it? Monica, read.
A maximum displacement of vibrating particles from the rest position is called amplitude. There, there are two amplitudes in a complete wave cycle.
What is complete wave? That is also known as cycle, right? Cycle means
Mm-hmm.
one complete wave. So here we got other name of wave, that is cycle, and we also can give it more two names. I'm writing also them. So please write this definition. You wrote the heading amplitude, right?
Yes, sir.
So write this definition, and while you are writing the definition, also write what I'm writing more here. Besides cycle, you give one slash, then you write oscillation, Oscillation. Then after writing oscillation, you write vibration.
Mhm.
So one thing, we have four names. Okay, we can say complete wave, or complete cycle, or complete oscillation, or complete vibration. And after writing this definition, you draw this diagram also. Hmm. You draw this diagram where we are showing the amplitudes. You write. You do not need to draw everything from here. You just draw the way I'm showing here. You see, I'm showing here. This way you draw. Here we have another line. So this way you draw, and here you give one arrow, another arrow give from here. Okay, so this both are amplitudes. You label this both as amplitudes. Okay, this way you draw. Then your drawing will be easier, right? What do you think? This drawing is easier, right? Hello, hello, Monica
Yes,
Mahi.
sir.
This drawing is easier, right? So I'm making your life easier.
Yes, sir.
Amplitudes. Yeah,
Thank you.
amplitudes. Amplitudes. You write amplitudes
Yes.
because in a complete way we have two amplitudes. We have two amplitudes. So amplitude has also a unit, that is displacement. And from the rest position is displacement. Its unit also like distance. That's why we are writing SI unit of amplitude is meter. Is also meter. So done. Amplitude is done, right?
Yes, sir.
Then after that we have frequency. After amplitude is done, we are having frequency. Write the heading frequency and try to understand what is called frequency. Frequency, you might know it before, right? What is called
Yes, sir.
frequency? Frequency, you see, in this diagram, we have some crest and some troughs, right? Look, we have one, two, three, four crest, and we have one, two, three troughs. So we are only taking three crest and three troughs. And for this three crest and three troughs, we are saying there are three complete waves, isn't it? How many complete waves?
Three complete waves.
Yeah, three complete waves, or we can say
Wait.
three complete cycles, or
Oh.
we can say three complete oscillations, or we can say three complete vibrations. Okay, and for these three complete waves to travel, we need 1 second. How much time is related here? How much time?
1 second.
1 second.
1 second.
Okay, so three complete waves in 1 second. That's why we are saying the frequency is 3 hertz. Okay. So what is frequency? Frequency is the number of complete waves in every second or per unit time. Is it clear to you?
Yes,
Hello.
sir.
So you write this
Yes,
definition,
sir.
please. Yeah, you please write this definition. The number of complete waves or cycles per unit time. Per unit time means per unit second is called frequency. Frequency is represented by F, and frequency is measured in hertz. Frequency is measured in hertz.
Her.
Now, I will not tell you to draw this diagram. I will tell you to draw a simpler diagram, and from there you will calculate. Okay. Now, I'm drawing here. Uh, are you done with this definition?
Yes,
Hello.
sir.
Okay. So, if you are done with definition, I
Yes,
will
sir.
go to. Are you done, Mahe?
Yes, sir. Yes, sir.
Okay, I'm going to a clean place where you can see properly. Yes, this place is much more cleaner. So here you go. You draw the way I'm drawing. You give a line here, y-axis, and here you give x-axis. And you draw this way. So my drawing is not that good. You draw nicely, huh? 1, 2, 3, 4, 5. Okay. How many complete waves are there?
5.
5. And you
Five.
label it here 2 seconds. Okay. 2 seconds. For this complete 5 waves, we need 2 seconds. So you label also the time. Then you find the frequency. What is the formula of frequency? You write here frequency. Frequency equals number of
Complete
complete
waves.
complete
Waves.
waves. Yes, waves divided by time taken, right? Time taken. So you have here our for our this question we have frequency equals number of complete waves. How many? How many?
5.
5. Then seconds, 2 seconds, right?
2 seconds.
Then we are getting our answer. How much? What is the answer? 2.5, right?
2.5.
You can say point per second, per second, or we can say hertz. In short, when you are writing hertz, it will be capital H Z. But in complete word you are writing, this will be like HERTZ, small letter, huh? As it is after the name of scientist. Is it clear?
Yes, sir.
So you got the formula here, you got the example, you got the drawing, and also you solved it, right? With the units, everything is done. Okay, now your life is much more easier. You can find any numerical questions giving you this number of waves and time. You can find the frequency, right?
Mm-hmm.
Hmm. So are you done?
Yes, sir.
Yes, sir.
Done, Mahi?
Yes, sir.
Okay, great. Now we are done with frequency. Now we have a formula of speed. We know now wavelength, we know now frequency, so you can apply now the formula of speed. Here we go. Here you go. So this one you write speed. Speed completely you write. Here we have very small things, little bit we have, so you write everything from here. Speed of a wave is the product of frequency and wavelength. So we can write the formula: speed equals frequency multiplied wavelength, v equals f lambda. The SI unit of speed is meters per second. Okay, are you done? Speed.
Yes, sir.
Okay, now we are going to learn waves more. There are different names of the waves depending on their behavior or their properties. So depending on the behavior of the waves, we have two types of waves. One is longitudinal, another one is transverse. So you write the heading longitudinal wave. First you write longitudinal wave. Have you written longitudinal wave?
Yes, sir.
Okay, look here. First diagram here, you see the spring. Spring is pulled and then pushed, right? Yeah, so the spring's particles movement is forward and backward, right? Or we can say left and right,
Okay.
isn't it? And the energy is transferred to the right side. Okay, the movement of the spring is forward and backward or left and right, but the energy transfer is right side. Okay, this
Yes,
spring
sir.
is attached at this corner, right? So
Yes, sir.
this energy is transferred till to this corner, right? That's why we are saying the energy transfer is happening to the right side. Now other diagram, you see the same spring, we are moving up and down. That time we are having the spring particles vibration upwards and downwards, but the energy transfer or energy transport is again it is right side, isn't it?
Yes,
Hello.
sir.
So this one uh, and the first one, there is a difference, right, in the movement of the particles of the spring. The first one, the particles movement or particles vibration is forward and backward, but the second one, the particles vibration is up and down. Okay, and the energy transfer in both the cases it is right side. Now this one we can say the energy transfer is parallel to the vibration of the particle in the first diagram, right? It is called parallel, right? Right and left.
Yes.
So energy
Yes, sir.
transfer and the particle's vibration is parallel here. But here you see either you are going up or down. In both the cases, you see the energy transfer is happening right side. That's why the angle it's making, it is 90-degree, right? Isn't it? The particles vibration, if it is upwards with energy transfer direction, it is making 90-degree, isn't it?
Yes, sir.
Again, if it is going downwards, it is making 90-degree. So the first case we are having, this is parallel, and the second case we are having perpendicular. We can say it perpendicular, right? Isn't it? Hello?
Yes, sir.
Particles vibration is
Sir.
perpendicular with the energy transfer direction. So I think the diagram you understood, the explanation you understood. Now we are going for the definition. This one, longitudinal wave heading you already wrote, right?
Yes, sir.
Okay.
Yes,
Now,
sir.
now you write this definition. Can you read it, Monica? This definition.
In a wave, if the vibration of particle is parallel, left and right, with the direction of energy transfer, then it's called a longitudinal wave. Example of longitudinal waves include sound waves, ultrasound waves, seismic P waves. P waves mean pressure or push waves which are created due to compression and rarefaction, expansion of particles of the medium, solid, liquid, or gas.
Okay, look here. We are having a new term. Maybe this word is new for you. Rarefaction. Rarefaction means expansion. Okay, is it clear? Expansion, you know, right? What is called
Yes, sir.
expansion? You see in the diagram we have expansion of the air molecules, and here we have compression of the air molecules for the vibration of tuning fork. This is one instrument known as tuning fork. This is used in our lab, physics lab, and also it is also used in some medical purposes. Tuning fork. Okay. So here you write only these two sentences, the first two sentences. In a wave from here till seismic P waves. So are you done with longitudinal wave?
Yes, sir.
Then write about transverse wave. Now
Okay, sir.
write the heading transverse wave, then definition you write, and the examples. During examples, you write this, water wave, then light waves. These two are common, okay? Then seismic S wave. Don't write all the things about example. You write only this, You write water waves, water waves. Here you write water waves, then light waves, then write seismic S waves. etc. Other things are available in your Google Classroom. From there you check. Okay. From here to here, right? You just write this word, examples. Examples: water waves, light waves, seismic S waves. Done?
Yes.
Okay, so you already have ideas about reflection. This reflection we are now having for the water waves. You see, try to understand it. You uh, you are seeing one diagram, right? That is showing you red color and blue color. You see this green color one is the surface from where the water wave is reflecting back, and the incident wave is shown by these parallel lines. These are the wave fronts. These parallel lines are showing you plane wave front, and the plane wave front is coming the direction showing with the arrow, and it's returning back reflected wave, another arrow that is blue color. Okay, again we are having the plane wave fronts. Here we are getting the reflection. That's why the law of reflection is followed here. That is, angle of incidence will be equal to angle of reflection. Okay. If you draw one normal here, here you go. This point is normal. This is normal. So you'll get angle of incidence and angle of refraction are equal. Is it clear? Hello?
Sir?
Hello? Is it clear?
Yes,
The
Yes,
sir.
sir.
angle of incidence and angle of reflection are equal. So you write this definition here. From here, reflection. From here you write reflection. Can you read Mahi this part?
Yes, sir.
Reflection. Yeah,
Uh,
reflection.
The reflection of a wave is simply a process by which a wave, whether light, sound, infrared, or water waves, hits an object and bounces off it. But this reflection looks quite different for a mirror than it does for a wall. For
Okay.
water wave diagrams, we can
Yeah, continue.
fronts. The wavefronts are the peaks of the waves and will always be at right angles to the wave direction as shown above. The distance between the wave fronts will represent the wavelengths. The closer the wavefronts are together, the shorter the wavelength of the water wave.
Okay. Wait. So here we have the heading reflection, right? Hello. Uh,
Yes,
so
sir.
Yes,
so you write this heading, then write this part. Till here you write.
sir.
Till here you write. From here to here, right? Okay. Then you write this part from here to here. Okay. So this part, last part, did you understand?
Yes, sir.
What they are saying, the two lines here, this gap, this gap is known as wavelength. Okay, is
Okay,
it
sir.
clear? So this
Yes.
part is known as wavelength. This is very important. We will need it afterwards, so you label it. Please draw this diagram also, huh? Label these things. What I labeled here, I R. You labeled here in this diagram. We are having I and R. It should be equal. Okay. This is law of reflection. Okay, Monica, could you please take the snap of
Yes,
this?
sir.
Yeah, take the snap of this, please. This diagram and reflection. You take the snap and send
Sir,
it
can
up.
you go a little up?
Little up.
Can you go a little up the page? Yes, sir.
No, no, it's not possible. You just take the diagram. That's it. The writing we don't need. The down part we don't need. Okay. If I move up and down, then this drawing will move also. Then your picture will not come correctly. Is it clear? Yes. Are you done?
1 minute.
Yeah, Mahe, are you done?
Yes, sir.
Hmm. Drawing is also done. Drawing.
Yes, sir.
So you will do one favor for me. That is, you will as scan your notes, huh, on this topic. Hello.
Yes, sir.
You will scan this note. When we will be over
Okay, sir.
with this topic,
Okay,
you will
sir.
scan these notes and you will send me in my email physicsmania.bd@gmail.com here in PDF format, a single file. Okay. From your mobile,
Okay,
you
sir.
can do it.
Okay,
There's
sir.
doc scanner apps. You can do it with app. It's very easy, not that difficult. So done. Both of you are done with drawing.
Yes, sir.
Yes, sir.
Okay, now we are going to last part. You see refraction. Okay, this part is showing you the bending of the wave. Okay, so here we are getting two things very important. Let's read it, then we'll understand some, and the rest part I will explain. Can you read, Monica?
Which one? The refraction?
Yes, refraction, please.
Refraction of wave involves a change in the direction of waves as they pass from one medium to another. Refraction is the bending of the path of waves. It is accompanied by a change in speed and wavelength of the waves.
Yeah, read also the diagram.
Similar to light, when waves enter a region of shallow water at an angle, the waves will refract.
Hmm.
If you place a plastic sheet at an angle, the change in speed of the waves will cause them to bend.
Okay, now here some of the things, very important things you have to remember. One is You see, light is traveling from deep to shallow region, right? Here, from
Yes, sir.
this part, left side, it is deeper region, and the right side one, this one is shallow region. So when it's going from deep to shallow, the speed of the water wave changes, speed decreases, and as
Mm-hmm.
the speed decreases, the wavelength also decreases. You see, here between the two lines, the gap we have, this is more, right? And the gap between
Yes, sir.
here is smaller. That's why the wavelength is less. So the one with have greater wavelength, we have more speed, and the smaller wavelength, we have less speed. Okay, and another important thing we have to remember, that is for the same source, we have the frequency same. Is it clear to you? Like here the source is only one source of water, right? Only one source
Yes,
of
sir.
water. So here the frequency of the wave will be same, but what is changing? Wavelength. Wavelength is changing, right? Wavelength was bigger, now wavelength
Yes.
is smaller. That's why the formula of speed, can you remember? It was V equals F lambda, right? So,
Yes,
so
sir.
from that formula, we understand that speed will be more in this uh, deeper region, and speed will be less in the shallow region. Is it clear now?
Yes,
Hello?
sir.
So please
Sir,
write this definition. Please write this definition. Refraction. And write whatever I'm writing. After writing the definition, frequency is very important information. Frequency, frequency of the wave is same for the same source. Frequency of the wave is same for the same source. Then another information is here, right? When water wave travels from deep to shallow, speed decreases. So our time is over, right? Speed decreases.
Mm.
Please finish writing this part.
Sir, will we give the note today?
Yeah, here, no, no, not today. Next class, we will finish, then you give, okay? Not today.
Okay, sir.
Thank you so much, huh?
You're welcome.
Okay. Allah Hafiz. Bye bye.
Allah Hafiz.